In the context of the Horizon 2020 ICT-18-2018 5G MOBIX project, WINGS ICT Solutions is leading the second use case of the Greek-Turkish cross-border corridor entitled Assisted Zero-Touch Truck Border Crossing and Increased Cooperative Awareness. The goal of this use case is to optimize the efficiency of customs inspection operations by minimizing human intervention in mundane tasks, resulting in reduced waiting times, performing intelligent threat assessment and classification of incoming trucks, and maximizing the security and safety of border crossings in general. The Greek-Turkish cross-border corridor at the Kipi-Ipsala area of Southeast Europe will be equipped with 5G communication capabilities, roadside infrastructure, and autonomous trucks provided by Ford to allow for advanced, cooperative, connected, and automated mobility trials utilizing 5G connectivity. Even though the trials are scheduled to begin in April 2020, WINGS ICT Solutions has already developed initial versions of the functionality and software required to support this use case, which is showcased in this demo on a small-scale model utilizing USRP-based connectivity. The demo showcases data ingestion and fusion from roadside sensors and vehicle onboard sensors, which will lead to some actuation based on the analysis performed at the WINGS cloud platform. The demo is comprised of the following elements: a connected vehicle, i.e. model truck, which is connected through open-air interface and is equipped with multiple onboard sensors, namely NFC tags and corresponding NFC reader, a CO2 sensor, a proximity sensor, a GPS sensor, and a license plate to act as input for the roadside cameras. The sensor-based infrastructure in the surroundings of the customs providing relevant readings is comprised of a camera with interconnected license plate recognition software, a thermal camera, an intelligent traffic light, and an intelligent border security bar. The two neighboring 5G networks of Greece and Turkey are emulated using USRPs and open-air interface, both connected to respective edge cloud nodes. Finally, data ingestion and analytics software provided by WINGS resides both in a centralized cloud as well as at the edge nodes to facilitate low latency communication. Two graphical user interfaces are provided with live feed from the cloud platform with relevant information and sensor readings for the customs agents and for the truck driver. These components are integrated into the functional architecture presented here. For a zero-touch border crossing to be realized, the intelligent WINGS cloud platform uses as input the CO2 readings, the license plate number recognized, the thermal imaging of the truck, the NFC read cargo ID, the proximity to any potential obstacles or humans, the GPS coordinates, which are emulated here due to the indoor nature of the demo, and the truck cargo manifest providing legal and register information of the truck. The corresponding output that may result in a zero-touch border crossing is a truck threat assessment and classification, which in turn actuates the traffic light and border gate bar, while it transmits automated driving instructions to the incoming truck. The demo showcases the applied functionality and resulting actions under four main border inspection scenarios. Scenario 1. Mismatch with the declared and registered information such as license plates or undeclared cargo. Automated number plate reading functionality allows for the easy integration of our technology with legacy customs infrastructure. As the truck approaches the border control, the roadside camera captures an image of the license plates of the truck, which is immediately processed in the cloud and benchmarked against the declared license plate number in the truck's manifest, available through the neighboring country's customs authorities. If a mismatch between the declared license plate and the actual license plate is detected, then the border gate bar closes and the traffic light turns red while the truck is autonomously directed to stop. The relevant information and the reason for the security check failure are displayed both in the customs agent's graphical user interface as well as the truck driver's graphical user interface. In a similar case, as the truck approaches the border control, the onboard or potentially roadside NFC reader is transmitting the NFC tag IDs attached to each cargo crate contained within the truck's cargo hold, and an immediate cross-check with the declared cargo ID on the truck's manifest is performed. If the transmitted cargo ID doesn't match the declared cargo ID, Then once again, the border gate bar closes and the traffic light turns red while the truck is autonomously directed to stop, while all relevant information is displayed at the respective graphical user interfaces. Our second scenario focuses on the protection and safety of the border personnel and is also applicable in urban environments to achieve vulnerable road user protection in densely populated areas. As the truck approaches the border control, the onboard proximity sensors are continuously transmitting the distance to the closest detected obstacle. These readings are continuously monitored by the WINGS Edge platform, and if an obstacle or human is detected in a distance lower than a certain threshold, then the border gate bar closes and the traffic light turns red while the truck is autonomously directed to stop. In this manner, the protection and safety of the customs agents and border control personnel is always guaranteed, while it becomes evident that the ultra-low latency of 5G connectivity is necessary in order to effectively realize this use case. Our third scenario is focused on preventing smuggling attempts such as illegal livestock or even human trafficking. As the truck approaches the border control, the onboard CO2 sensors mounted in the cargo hold are continuously transmitting the readings to the WINGS Edge platform, where depending on their level of potential risk assessment for the presence of human or livestock in the cargo hold is performed. If the CO2 readings indicate that the probability of a smuggling attempt is higher than a predefined threshold, then the roadside thermal camera is activated to scan for heat signatures within the cargo hold of the truck. If the thermal camera readings also confirm the potential presence of a human or animal in the cargo hold, then the border gate bar closes and the traffic light turns red while the truck is autonomously directed to stop. This is an extremely relevant use case according to customs authorities due to the immigration crisis and multiple smuggling attempts taking place at the European borders. Finally, a legitimate operation scenario qualifying for zero-touch border crossing is showcased. As the truck approaches the border control, all the relevant information from the onboard and roadside sensors are collected and processed by the WINGS Edge platform. In the case that all sensors are transmitting as expected, meaning that no malfunctions or mistransmissions have occurred, the data transmitted are cross-checked and verified with a manifest, meaning that the cargo ID and license plate get verified, and that no threat is detected by the remaining sensors, CO2, proximity, and thermal imaging. Then the truck is considered to have passed remote inspection and is cleared for passing the borders. In this case, the traffic light remains green, the border gate bar remains open, and the truck performs a zero-touch border crossing. In emergency cases, the developed software allows for a manual override of the border gate bar by the customs agent to allow them to intervene and secure the borders at any time based on their situational awareness. In conclusion, WINGS ICT Solutions has established the framework, functionality, and infrastructure to enable assisted zero-touch tracked border crossing with its intelligent functionality residing at the edge, prompting autonomous driving decisions at the customs area. In order to set up the real-life pilots that will be executed at the Greek-Turkish borders, WINGS actively collaborates with Cosmote and Turkcell, which are the mobile network operators providing the network, Ford, which is the original equipment manufacturer providing the autonomous trucks, and Ericsson Greece and Turkey, which are the vendors providing the 5G components. For our future work, we will demonstrate this functionality at the project review set to take place in July 2019, while further development of the functionality to utilize extended sensors and to produce additional intelligence will take place. Integration in the field will follow once the Cosmote Turkcell 5G networks are deployed at the Greek-Turkish borders, while the collaboration with Intelligent will bring further AI-powered customs intelligence to the use case.